Okay, in this video tutorial we're going to look at the mathematical strand of number, and more specifically we're going to look at focusing on how to write numbers as a product of their prime factors. So essentially what is meant by product of prime factors? Well, the first thing you need to do is you need to know what your prime numbers are. Now remember that a prime number is a number that has only factors of 1 and itself. So examples of prime numbers might be okay, we've got 1, 2, 3, 5, 7, 11, 13, 17, 19, etc. Because all these numbers only have factors of 1 in themselves. And the next thing you need to know is what a factor is. Now recall that a factor is a number that can be equally divided into another number. All right, so for example, a factor of 10 is 1, 2, 5, and 10, because all of those numbers can be divided into 10 without giving a remainder. So to write a number as a product of its prime factors, you first need to divide the number continuously by prime numbers until you can't divide anymore. Okay. You then write the numbers in index notation, and you can either do these by a factor tree or by a factor ladder, and we'll go through an example of what all that actually means in a minute. So we'll look at some examples. The first one, it says write 42 as a product of its prime factors. Now remember that our prime numbers are 1, 2, 3, 5, 7, 11, 13. I'll write just those ones because I don't think we'll need any more. But obviously there are some more prime numbers as well. So if we want to write this product 42 as a product of its prime factors as a factor tree, okay, first thing we want to do is we want to write the number 42, and we're going to start dividing by prime numbers. Now we won't divide by 1 because 1's a special number, so the first prime number that we want to try and divide by is 2. If we divide 42 by 2, that gives us 21. We then want to divide by a prime number as well. Now obviously 21 is an odd number, so we can't divide it by 2. So let's try and divide by 3. And that gives us 7. Now you'll notice that 2, 3, and 7 are all prime numbers. When you get up to a prime number, we can't divide anymore because it's only got factors of 1 in itself. So 42 is actually written as 2 times 3 times 7. If you wanted to do a factor ladder, okay, we'd have 42 down this way, all right, and we'd divide by 2, which would give us 21. We'd divide by 3, which would give us 7. We'd divide by 7, and that would give us 1. And therefore, we've got these numbers here, which is 2 times 3 times 7. If we wanted to do the same thing for 60, all right, if we wanted to do a factor tree, we'd divide by 2 first, because we know it's an even number. That would give us 30. We could divide by 2 again. That would give us 15. I'd try and divide by 3. That would give us 5. And you'll notice that these are all prime numbers. If I wanted to do my ladder, I've got 60. I'm going to divide by 2, that's going to give me 30. I'm going to divide by 2, that's going to give me 15. I'm going to divide by 3, that's going to give me 5. I'm going to divide by 5, and that's going to give me 1. And our ladder always stops at 1. Again, we've got our numbers here, so we can say that 60 is actually 2 times 2 times 3 times 5. Now we can actually use index notation here because we have 2 lots of 2. So we can write 60 actually equals 2 squared times 3 times 5. Oops. Okay, I'd now like you to go have a go at some practice questions. They'll come up in a couple of seconds. If you could pause the video, have a go at them. When you think you've got them correct, continue the video and we'll go through the answers on the last slide. So as stated here, the practice questions, they're asking you to write 48 as a product of its prime factors and 90 as a product of its prime factors. Pause the video, have a go, and we'll go through the answers on the last slide. Okay, so let's see how you went. Remember, we can use factor trees or we can use factor ladders. So if I wanted to use a factor tree, I would write 48, divide by 2, that would give me 24, divide by 2 would give me 12, divide by 2 would give me 6, divide by 2 would give me 3, and you would notice that all of these are prime numbers. If I wanted to use my factor ladder, again, I'd have 48, I'd divide by 2, that would give me 24, I'd divide by 2, that would give me 12, divide by 2 would give me 6, divide by 2 would give me 3, divide by 3 would give me 1. So we can see that 48 is actually 2 times 2 times 2 times 2 times 3, which is actually 2 to the power of 4 times 3. And that would be your answer using index notation. If we're going to write 90 using our factor tree, we've got 90. I'm going to divide by 2, it's going to give me 45. I'm going to divide by 3, it's going to give me 15. I'm going to divide by 3, it's going to give me 5. If I'm doing my factor ladder, I've got 90. I'm going to divide by 2, it's going to give me 45. I'm going to divide by 3, it's going to give me 15. Divide by 3, it's going to give me 5. Divide by 5, it's going to give me 1. So I can say that 90 is actually equal to 2 times 3 times 3 times 5, which then equates to, 2 times 3 squared times 5.